It turns out that plot2D, it's set up to show animations of functions of this form, where we need to specify a vector of times and produce the animation. We're going to show you how to do that by looking at this worksheet. To produce an animation, I'm going to create a range of vectors. This is simply times colon range comma, parentheses 0, 10, 1. Okay, that produces 10 or 11 values actually. If I use the equal sign right there, it's calculating something. I'm going to stop this in here, interrupt the process. And there's the times. Okay. So since that I have something ongoing, I'm going to have to enter the process and do a delete here. And I could have equally spaced times like I did in this case, or a set of non-equally spaced times that I defined separately, 0, 2, 5, 8, 12, and 20. Now I'm going to define a function, a relatively simple one, f of xt equals sine of x minus t. I'm going to delete this and show you from the beginning. What we're going to do is insert a plot2D, and I need to stop here. Okay, stop here. I'm going to do something. I'm going to eliminate the auto calculation. Do insert plot2D. I'm gonna increase the size of this. Hold the left mouse button and move the center, the origin to the center. And then what I'm going to do here is type the name of the function f of xt that I need. Since I have my calculations changed, I'm gonna have to do like recalculate page. But there's nothing being produced because I need to activate the animation. And so here, follow these instructions. Type f of t in the entry point. We did that. We're going to need to click in the middle of the point once to select it like that. Then do a right click in the middle and go for animate. And then we need to select the vector that we're going to use for animation, and we're going to select the vector times. And then when we do that, this is t not defined. The reason why it's not working, I need to go to calculation and do auto calculation, so we'll start automatically. And so I'm going to drag this back to the center. And you can proceed to change the amplitude, for example, by holding the control key and moving the mouse upwards. You may want to do this at this point. Stop the calculations, interrupt processing. We'll go to calculation, get the calculation, and then click on this graph. And then holding the control, the shift will, holding the shift key will change the range in X, and the control changes the vertical range. So anyway, you can change that, and when you go here and click and do a right click on animate, you can also change the frame rate, and you can go faster, even faster, or you can slow it down. Right? Now, here I'm going to show you animations of several graphics. I made up these functions which involve x and t, and created an all F system that includes F1, F2, and F3 of x and t. Created my own times in here. And for this graph, I am animating these three. And here I created other functions. These are more like a kind of a standing wave. Okay. And that's probably because in this case, I include the difference between x and t, so that produces like a moving wave, but a standing wave, the amplitude is a function of time only, and then the wave itself is a function of x. So this is a way to produce the animation of those waves. You can follow these examples on your own. And let's try a different example. I'm going to define a function f of u, w. In this case, of course, I'm referring to the u as x, and the w will be my time. And then I'm going to define a vector of times. This is what you need to type to produce the vector on the right-hand side. I'm going to go from values of an angle from minus pi to pi. With the second term equal to minus pi plus pi over 20, so the increment is pi over 20. I do exactly the same as I did above, typing f of xt here, clicking in the middle of the plot, selecting theta. I think I have a mistake here. Let me check. I'm going to click in here, do a right click, select animate, and it is times actually, not theta. So animate times should be the one that the instruction in here. Check. We can change the frame rate. So this is a function that is moving, but also the amplitude is decreasing with time, and so you get like a decreasing moving wave. You can modify the x and y ranges by holding your shift or control keys and moving using the mouse wheel, and you can go here, and when you click and do a right click, you can eliminate the grid or add the grid and eliminate axis. So you want to see just the wave, eliminate axis and grid, and you get the wave moving over here. And in this case, I go for pi is going, the times are going from minus pi to pi and then back from pi to minus pi. And so that produces kind of a wave that increases and then decreases, increases and then decreases. And I took out the axis and the grid in here. Okay, I have in video 517 a series of functions called statistics and graphical functions. I'm using them here because I added a couple of functions, one called parplot, that means parametric plot for animation, where I'm going to define my x and y in terms of parameters u and t, parameter u in the range u, u1, and so on. And in this way, I'm going to produce a matrix that's going to be a function of time. I'm indicating time here by the letter tau, the Greek letter tau, which is typed by using T, Control G. Okay, and whatever the first this should be a u actually. The parameter of the plot is u, and tau is the time. I'm using this times to control the time. For u, I go from 0 to 4 pi in increments of pi over 100. This is my f1 of u2, ut, and this is my f2 of ut, where I have an amplitude, another amplitude here, and those amplitudes are also sinusoidal functions. And so I'm producing my parametric plot and call it the matrix P for the plot. It's a function of tau, which is the time, and then you go tau as the second variable in the functions f1 and f2. And then I indicate the initial value, the ending value, and the delta u value for the parameter u, which I indicated over here. And then the parametric plot is just increasing and decreasing in size. Okay. And a second example, we're also going to use a sine, cosine, but we're going to use a different amplitude, and that basically produces a circle. A circle whose amplitude, whose radius is increasing with time, is generated by creating this matrix MP of tau. If we want to animate polar plot functions, we have a function called pplot a in that snippet that I included. You need to put the function of theta and tau, and then the initial and final values of theta. Tim is the time-dependent part. I go from minus pi to pi in increments of pi over 20. This is the function g of theta tau. Interestingly enough, if you can put t here, and you can put tau, and it won't make any difference. You can even change the name of the variable here to produce the matrix that's going to be function of time. As long as you put t in here, then you can get that function changing with time. Second example, g of theta tau equals 4 times x should be control g for tau theta, and even changing the variable here to s. As long as you put f of t here, you get that polar plot animated. For independent polar plots, we have the functions g, h, f, and r. And I'm creating matrices that depend on time for each one of them, creating a collection, system of functions, and then you can see those functions changing with time. Now, you may think, what do I need to use this for? It's at this point, it's mostly like for fun, for entertainment. You know, changing shapes of functions that are a function of time. And with that, we conclude this particular video. I'm going to show you some other interesting things in upcoming